So 9.4 is surface area of prisms and cylinders. So surface area. And I really enjoyed this type of thing. It kind of gets into what we were doing in the last chapter, like the 3D objects. Now you're trying to kind of like unfold them and then figure out the surface area of the different parts. So we're just kind of like starting to get into that a little bit today. But I have thoroughly enjoyed making the notes for this part. But I'm going to start out with the Roman numeral 1, just call that terms. And that way when you're reading the questions, you kind of know what they're talking about. You're able to better figure out the answers. So first one is a polyhedron. So poly means many, right? A polyhedron, I want to say two things about it. First thing, it's going to be a three-dimensional object. So I'm just going to say like 3D. And polyhedron kind of goes along with like polygon, the many sides. Each face or each surface of one of these polyhedrons is going to be a polygon. So I'm going to say each face. Or if you wanted to, you could say like side. It's kind of as another word for face. Is a polygon. Does anybody remember the corners like of a triangle or a octagon? What each corner was called? Vertex. Nice. So same sort of thing is going to be true here. So the vertex, and if you didn't have that in your head, you could write it down. But the vertex then, that's really just saying it's like a corner of one of these polyhedrons. And now the surface area. So surface area. We're going to start abbreviating that because it's a real pain to write, especially you keep messing up the A on the iPad. Okay, surface area, usually just do a SA for surface area. And what that is going to be, it's going to be the sum or the total if you're adding. So the total of the areas of all the sides. When we talk about the surface area of one of these polyhedrons, we're trying to figure out the surface area of each surface of each side, and you add them all together here at the end. Still good? All right, so then prism is the next one. So a prism is going to be a polyhedron with two congruent or two parallel faces. So it's going to be a polyhedron, a 3D object that has all the surfaces being a polygon with two congruent, and by that we just mean that they're the same, they're identical, parallel faces. Let's squeeze that in there. And these two congruent parallel faces, they refer to those as the bases, so called the bases. So it's kind of like if you could picture if you set something on like one of these surfaces on one base, and the other base is going to be parallel to the ground above it. So I'm going to flip ahead a second to a picture, and I can come back to that if you want. But like this here would be, I'll get rid of my pen. There we go, finally. So those shaded ones are going to be the bases. That it might not be sitting on it, like for my first one over here, it's not sitting on the base. We have this triangle over here, we have an identical triangle over there, and they're parallel to each other. So those have to be the bases even though it's not sitting on it. And same type of thing here for this cube, but now we have the base there, the base there. Although technically, if this really were a cube, any two opposite sides could be the bases, right? If all the sides are the same length. For if you have more of a rectangular shaped cube, if that's a word, you know, your bases have to be this edge and that edge. So for these here, so on. But make sense? Anybody need to copy down kind of the definition a little bit more, or are we good? So this here, does anyone remember what the object on the right is called? Nice, the net. So that's going to be our next definition is a net, and that's what we were doing at the very end of chapter 8. Where a net was like the unfolded 3D object. If I took this here and kind of, if it was made out of paper, if I cut the edges of the paper and unfolded it, it would give us the object here on the left. So the net, I'm going to say, is an unfolded 3D object. So unfolded 3D object. I don't know if you want to try to quick draw something like that. My guess is you probably don't need to. It just triggers your mind enough. So. Okay on those? Then if we were to go through and look at like nets for other things, this would be like another one where we have a net. Start out with this kind of like cube-shaped object. They start showing kind of like it being unfolded and then laid flat. So that's like another net of something like that. This next one I thought was kind of cool. And it makes sense to me, but at first it seems kind of weird. But this is what the cylinder would look like if you did a net. Cylinders. But you have your top and your bottom. Your bases are going to be the two circles. Then if you did a slice like here along the edge and unfolded it, so it's kind of like unfolded that way and that way, you just have this big old rectangle, which is the whole side. Seem to make sense? So I thought that was kind of cool. Roman numeral 2, finding surface area. And what will make this a whole lot easier is I gave you that bookmark a little while ago with the equations for like finding the area of a whole bunch of different shapes. So that should help. So finding surface area. And the key to this is you find the area of each part and add them together. So find the area. I'm just going to do a capital A for area. Find the A of each part. And add them together. So find the area of each part and add them together. Figure kind of go through and do that for one of my examples and then call it good for the day. All right, so if I were to jump back to this one, I kind of thought we could go and do this one here. And what's I think easiest is to go through and do that for this net shape instead. If I were to go through, let's say this. All right, so let's say example 1. Find SA, find the surface area. Now for that, how many areas do we really need to find? So really we need to find the area of the greens and multiply by 2. Find the areas of the blue, multiply by 2. Find the areas of the red, multiply by 2, and add all those together. We good? So one way is to go through and get those different areas like that. Another, which I suppose starts getting a little bit kind of makes me nervous, but in theory you could, do you agree, combine that green and blue together? And then when you double it, that'd give you this green and blue here. So you could kind of, instead of saying the I don't know, base is going to be 30, you could say the base is going to be 35, and then include kind of the green and the blue together in one. I think I'm going to avoid that just because I think that might make it more confusing for some. And I'm just going to go through and do it as 3 different parts. So if we were to get the area 1, I'll call it, of this green, that's going to be, so that first one's a rectangle, so I'm going to say base times height. And I'm going to show my work because I'm really hoping you will. Okay, base is going to be 30 times a height of 24. So if we were to take and do those two together, we get 720. And now we have 2 of those, right? Maybe we'll come back and do that, 2 of them in a second. All right, so I have that. If I'm trying to do my second area, those in blue, I'm going to maybe say it's a sub 2 just for second area. That's not like a squared. But now what's going to be the dimensions of those red ones? So it's base times height. My base, if I look at this blue one, my base has to be the 5, right? And my height is going to be 24. So that's going to be 120. So we have that number there. And now my third section is going to be my red, so I'll say a sub 3, and we have another rectangle, so base times height. Now, what's my base going to be? 30, yep, because if this is 30 over here, then like it's going to be 30 there, because that's like right on top of the object. So I have a base of 30 times a height of 5 still, because each of these edges were 5, so it's 5 here. Trying to write real small, but so that's 5, this is 5. So 30 times 5 gives me 150, right? Okay, now I had 2 of those red sections. That's going to be a total of 300. I had 2 of the blue sections, so 120 times 2 is 240. And I had 2 of those greens, so 720, 1440, nice. And maybe I should be writing times 2, times 2, times 2. But now if we add all those together, I get the first 2 gives me 1680 plus another 300. Total area, 1980. So the surface area, 1980. I think for some people, the biggest challenge is just going to be staying organized. That it's easy to kind of lose yourself in the problem. So you might want to actually go through and label things like A1, A2, A3, or maybe as you find the area of something, put a box around it and then kind of like shade that in, just so you don't lose track of what you found and what you haven't found. But I think they're kind of fun to work through personally. Yeah, it's probably a good idea to put the units on it. It's not going to be 1,980 squared, but it's going to be those units squared. So it's 1,980 square what? Centimeters. So I'd have to write a centimeter squared after it. So make an excellent point. Thank you.